right, for this lesson, we're doing sections 4.4 and 4.5. We're going to focus on more proofs using, this time, cpctc, or as I like to say, okay, so practice pronouncing that, and you can try it out in class next time. Isosceles and equilateral triangles, which you already know a little bit about. Let's start with cpctc. Everything stands for something. It's an acronym. C, corresponding parts. So we're talking about the same part in one triangle that compares to the same part in another triangle. Corresponding parts of congruent triangles are congruent. All you have to do is remember the acronym, cpctc. If you prove that two triangles are congruent using any of the 5 postulates, then you can say that any of the 6 corresponding parts are congruent by cpctc. Let's practice. This first one, we're given that BD bisects angle ABC and that BD is perpendicular to AC. I may need to do some extra information with this perpendicular. We'll see when we get to it. Okay? I'm trying to prove, though, not that the triangles are congruent, but that side AB is congruent to side CB. So the first thing I have to do is prove that the triangles are congruent. All right, so we got BD bisects angle ABC. I'm going to outline angle ABC so that I know exactly what happened here. What that does, since it bisects it, means that angle 1 and angle 2 are congruent. Since I wrote it or marked it, I'm going to write it. Angle 1 is congruent to angle 2, and my reason is definition of angle bisector. Okay, let's see if there's any other information we can use here. I know that BD is perpendicular to AC. So BD is perpendicular to AC, creating a right angle here and here. You don't have to draw both boxes in, but what that tells me is that for statement number 3, here we go with our next 2 statements, that both angle 3 and angle 4 are right angles. The reason being definition of perpendicular. Okay? So now, because they're right angles and all right angles are congruent, then we know that angle 3 is congruent to angle 4. So the measure of angle 3 we'll say is equal to the measure of angle 4, which equals 90 degrees, because all right angles are congruent. Okay, so you guys should be getting really good at that one by now. Every time we see perpendicular, we follow it with 2 steps. Do I have enough information to prove the triangles are congruent? Looking at my picture, I only have 2 angles congruent to 2 other angles in the other triangle, so not quite enough. But if you look at it, we have this reflexive side. So I can say that side BD is congruent to side BD by, put this up here for a second, reflexive property. All right, so proving the triangles are congruent, we are just about there. I can prove it by angle, side, angle. So triangle, and this time we have to be careful how we name it. I'm going to say ABD for the first one is congruent to triangle. And figure out what goes with A. A goes with C in this picture. B goes with itself in this picture. And D goes with itself in this picture. And I know this because of angle, side, angle. Even though there's a right angle, I didn't want to use hypotenuse leg because I don't have the hypotenuse marked in either triangle. That's not what we're trying to prove, though. We're not trying to prove the triangles are congruent. I want to prove that AB is congruent to CB. Well, if the triangles are congruent, all 6 corresponding parts are. So, side AB is congruent to side CB by cpctc. So it's the same proofs you've been doing, just add on that 1 extra step. Sorry, we're missing some parts of this.
So go ahead and copy this down. In the next couple proofs, we want you guys to pause it and try it on your own, because if you realize it's the same steps except for adding 1 extra step now, because we're not stopping at the triangles congruent, we're stopping at a part. So go ahead and see if you can complete this proof, pause it, and then we'll get back to you. All right, so here's the answers. Let's just read through it real quick. C is the midpoint of BE, so that's why you can have that marked. In the given, they do give us that B and E are congruent, so I'm going to mark that. And then since we have vertical, we can mark those. So those should all be marked. That's how we got angle, side, angle. And then after we get angle, side, angle, we can go to cpctc. So let us know how you do back in class tomorrow. All right, same thing here. Go ahead and pause it and see if you can get all of the steps done correctly. And here we go.
So anytime you get parallel lines given to you in the picture, there are either two types of angles that are going to show up, either alternate interior or you're going to see corresponding angles. So in this particular picture, I know that this right here, since CB or BC is parallel to AD, I can create my zigzag, which gives me my alternate interior angles 2 and 3. Then I can create my zigzag the other way using the other parallel lines, that 1 and 4, so AB, go through the transversal up to DC, and I've got that angle 1 and angle 4 are congruent, and both of those are alternate interior angles. I like to call them my Z angles because they make zigzags when I look for them. All right, to continue on, we've got a reflexive property that BD is congruent. So far we've got 1 and 4, 2 and 3, and BD, which gives us enough to prove that the two triangles are congruent by angle, side, angle. And last but not least, angle A is congruent to angle C because of cpctc. All right, moving away from proofs, we're going to talk about the parts of an isosceles triangle. An isosceles triangle, remember we define this as having 2 equal sides. Those 2 equal sides are called your legs. And your legs, notice, are opposite your base angles, which are also congruent. So if 2 base angles are congruent, then your legs are congruent. If 2 legs are congruent, then the base angles are, and then we're talking about an isosceles triangle. This guy at the top, vertex angle, so that means this, not congruent to anything, so I'm going to take that arc out, is my vertex of the triangle.
For an equilateral triangle, hopefully you remember that all 3 sides are equal. Equilateral triangle is actually also an equiangular triangle, so hopefully you remember what that vocabulary word was. Equiangular, sorry, I never can spell right. Okay, that means all the angles are equal, so I'm going to go ahead and mark my arcs there. And so if we know they're all equal, then I can do 180 divided by 3, and notice that all equilateral triangles have angle degrees of 60 degrees. So anytime you see equilateral, you know automatically to put 60 degrees in there. All right, so we're going to go through these 3 problems. The first one, you see that the angles are marked congruent. That means that those are the base angles and the sides across are going to be congruent because those are our legs. So we can set them equal. 3x plus 4 equals 22. And when you go ahead and do your algebra work, you should end up getting x to equal 8, so make sure you can work through that. That's just the simple algebra problem. And it's just asking for variables right now, so we can stop at that.
I think I messed up on my math when I gave you that problem. It's going to be 18 divided by 3, so that's going to give us 6.
Thank you. Here we go. All right, so we're going to move on to the second one. It is also an isosceles triangle. That means that angles F and angle D are our base angles. So I'm just going to mark that congruent. There are actually 2 different ways you can solve for this. I'm going to show you both ways just so you can see. First off, we know that this angle up here at E, our vertex angle is 40 degrees, and then D and F are congruent. So if I just kind of redraw this here, and we know that this is 40, these 2 are going to be the same. So I can actually figure out what D and F equal, because we can do 180 minus 40, which gives us 140, and then divide that by 2. So we know that those 2 base angles are going to be 70 degrees. So I'm going to fill that in there now. Now that we know that 70, well, we are told that angle D is represented by 11x minus 18. So we can do 11x minus 18 should equal 70 degrees. And now we can solve for x. So you do your algebra work, 11x equals 88 and then x to equal 8. Okay, so that's one way you can do it. The second way that you can do it, I'm going to go ahead and erase this. If we know that angle D is 11x minus 18, then we also know that angle X is 11x minus 18 since they're the base angles. Well, what do you know about all three angles in a triangle? They should always add up to equal 180. So we can do 40 plus, and since these are both equal, I'm just going to do 2 times the quantity 11x minus 18 should equal 180. Squeeze that in there. Okay, so now we can do that our same algebra work through it, and you still should get x to equal 8, no matter what. So just figure out which way you want to do for the second one, but the third one, Ms. Hurst is going to show us that there is a specific way you're going to have to do it.
Because both base angles have different variables in them, one has an x and one has a y, I can't quite do the same approach and add them all to equal 180 that Ms. White just did in the last one. I'm going to go ahead and erase all this work so I have a little bit of room to do the problem here. So I'm going to use the first approach that she did, and I know since these two are in fact congruent, since they are base angles, if I do 180 minus 98, which is going to give me 82, then I can divide that by 2, and that gives me that 41 degrees is equal to both of these angles. So now that I know that those are both equal to 41, I've got two equations ready to go. 5x plus 6 equals 41, and then y minus 9 equals 41. So we'll go ahead and solve that so that we can find out what x and what y are. So 5x plus 6 equals 41, we're going to end up getting x equals 7. If we have y minus 9 equals 41, we're going to end up with y equals 50. Okay?
This one is asking for the perimeter. So let's take a look. What type of triangle is this first? If we see that all the angles are equal, they're equiangular, that means all the sides are equal. So this is equilateral. Well, they give us 3 sides. We don't just say all 3 are equal. You can pick any 2 sides. It really doesn't matter. I'm just going to put an equal sign there and say that 7x minus 17 is equal to 4x minus 5. So to find the perimeter, we first have to solve for a variable. Okay, so take the time right now to do that, and hopefully, going through your algebra, you get x to equal 4. Okay, now I'm just going to plug it back into either one, any of them. So 7 times 4 minus 17 should give you 11. So that means this side's 11 and this side's 11. And to find the perimeter of a triangle, all you have to do is add up all 3 sides. So a plus b plus c, which is 11 plus 11 plus 11 to give you the perimeter of 33 meters. And that's the perimeter of that triangle.
All right, this theorem. There are other ways to look at the example, but we're going to focus on what the theorem is saying. If you see an isosceles triangle, and I know it's isosceles because I've got the 2 legs marked congruent, and there's an angle bisector in them, notice that the angles here, the vertex angle, are marked congruent, then I can assume that this bottom part, the base of our triangle, got bisected as well. And not only that, but we had the perpendicular bisector. You don't need to necessarily memorize the symbols that we wrote down here, but the concept is what's important here. If you know it's isosceles and you have the angle bisector, then the angle bisector is also a perpendicular bisector of the base. Using that information, let's go ahead and work on this example here. All right, so they've marked my sides as being congruent and my angles as being congruent. So we know it's isosceles with an angle bisector. Therefore, I can also assume that this is congruent and that these angles down here are 90 degrees. I want to use that 90-degree information for this particular problem. If this is x over here, then this is also x, since they're congruent. We know that all 3 angles of a triangle add up to be 180. So I know that I have x plus 42 plus 90 equals 180. But a little bit easier than that, since there is a 90-degree angle in the triangle, I can just do, because if I move 90 over here, we get x plus 42 equals 90. You could have started off with that information. So x equals 90 minus 42, or 48 degrees.
All right, so tomorrow we would like you guys to bring in this question answer. So solve for x and y in this following triangle.
So we're not going to go over this one with you right now. This is on your own. Please have it ready so we can discuss it in class.